Hello and welcome to this course. This is the Statistics 2 course that we'll be doing in this program. You must have already done a Statistics 1 course and maybe the Mathematics 1 course in your previous term. In this term, we will take that forward and step into the second part of the Statistics course. This is week 0. We are not really starting the course. It's sort of like a prelude to the course, and we will generally look at statistics and probability and data from a very high level and sort of set the stage for what is to come in the rest of the course. Okay, so that's the main goal of a few lectures we have as part of week 0 in this class. Okay, it's an introduction to the whole course. Okay, so a quick overview. Hopefully you've learned the previous 3 or 4 courses that come in the first part of the foundational program, which is Statistics 1, where you learn to handle data, summarize in different ways, look at some summary statistics, and handle some simple probabilistic scenarios. And you were introduced to this in your first course. And of course, there were other courses, computational thinking, mathematics, English, etc. I don't want to say too much about it. So now we're jumping into Statistics 2. So this is sort of like an important course which is going to connect a lot of things for you. In particular, we'll continue our study of data, statistics, probability, look at connections between them, how one works with the other. And slowly, you'll also handle larger amounts of data in this class. Okay, so you will start getting comfortable with larger amounts, maybe try to understand the difficulties in handling large amounts of data using computer, etc. And we'll also consider more complex probabilistic scenarios, like slightly more advanced probability. And we'll study very important classical statistical questions and procedures. The formal syllabus of the course will be made available to you as a document, as a spreadsheet. You can look at it later on when you have time, but roughly this is the idea of the course. Okay. One important aspect with respect to grading in this class is that there is the usual thing that you are that in all courses in this program you must be doing, which is writing quizzes and exams, and that will give you 100% of the marks. In this class, I'm going to introduce some activities for you, and depending on whether you finish those activities or not, you may be eligible for a 10% bonus on top of the other marks that you have. So these activities are clearly not mandatory. You can get 100% even without them, but I think these activities are very crucial. They'll really help you, give you a hands-on feel for what this subject is and how to work with it. Okay, so that's the overview. Now let's get into the details of what are some more intricate details about data, statistics, probability, and some questions surrounding them. Once again, this is just an introductory lecture, so I'll be at a very high level to give you a broad introduction. Okay, so let's begin with, in a slightly more general way, go back to the very basics and think about how people study phenomena in science, right? So science is sort of like the starting point of many things, and you're curious about some things that you see and you're looking for explanations, you're looking for being able to use it in applications, maybe an interesting phenomenon, whatever, right? So that's how science began. And generally the way scientific theories work or science works is usually people begin with observations, some interesting observations, which provides, in today's language you can say, data. In those days, I don't know, they would have just said experimental observations and experiments, etc. But let's say we call them data. Okay, for instance, you can see some couple of pictures here which depict very famous maybe scientific observations for centuries. One picture shows an apple falling from a tree, and the other picture shows a solar system. People for centuries have observed the solar system, okay, and across the globe they've made notings of where different planets are at different times, and they've tried to find some patterns in this data, right? Or they actually already found some patterns in this data, right? You know, an apple, once it ripens and gets cut off from the tree, it falls towards the ground in sort of like a straight vertical line it picks up speed as it comes down. All these patterns were known, particularly with respect to the planets. Lots and lots of patterns were known for various other reasons. People knew that all this kind of phenomenon that you observe of movement of objects moving from one place to the other for various reasons, there is a pattern that they seem to follow. Okay, so these observations were all there, and one of the great achievements in science was these Newton's theories of motion, right? So the theory came along a little bit later, and one of the great successes of this theory is that it could, with some very simple equations, consistently explain all these observed patterns across the spectrum of movement of objects, right? So dynamics and mechanics of objects, this theory, simple theory with very simple equations and simple notions of force and mass and acceleration, one could explain all these phenomena in a very consistent way. All these patterns could be explained in a very consistent way. So that's what theory does, and when you have a theory which can explain all these patterns, you can put it to use. Okay, and the applications are plentiful. You can see all the applications of Newton's laws all the way around you. I don't have to say anything more. Okay, so this is how science works, right? This is how a proper, rigorous scientific study of a phenomenon works. Okay. So why am I saying all this? It's just to sort of give you a feel for where we are going in this entire program, maybe, or particularly in this course. We will also study phenomena. Okay, so some phenomena which produces some patterns in the data. Okay, so you get some data, and there's some patterns in the data, and there's some phenomena. We want to understand that. So in the large picture, we are doing the same thing as this, except that our approach and our data is going to have different type of patterns, and our methods will be different. Okay, so this is one way to think of how we work. Okay, so so coming to our course in particular, this notion of statistical study, there are, one can say, two types of patterns that one can observe in this data that you may generate from various observations or experiments or something. One would be sort of a deterministic pattern. For instance, you could think of position of an object which is moving, say, at a constant velocity. Then its current position is going to be initial position plus velocity into time. So that's like a deterministic equation, right? So you know the initial position, you know the velocity, you know at what time you want the current position. You plug it in, you get the answer. It's a very clear deterministic pattern which is explained with a very simple equation. Now, many scientific theories out there similarly use deterministic equations. Maybe not such simple equations. You already know from your maybe some physics you've studied that if the object is not just moving at constant speed but it's accelerating, then you have more terms. And in fact, if it's doing various other things, you have more terms. And as you look at more and more complex scientific theories, more and more difficult mathematics comes in, right? You'll have differential equations, partial differential equations, integration, all of that will come in. But all of that is not relevant for us at all, but I'm just pointing out that the mathematics can get a bit more complicated even when the pattern is very deterministic. You know what the pattern is, you to describe it, you need more complex mathematics. I can give you a lot of examples. Maybe a simple example is sound, right? The way sound travels from one point to the other. Usually in physics, people use something called wave theory for it. And then the patterns that wave produces in air is described using more complicated equations than this kind of equation. So, but still the philosophy is always the same. You observe something, you see a pattern, right, in a phenomenon, and you want to explain it with a consistent theory. Consistency is very important, right? So in some way, the theory has to work repeatedly in different scenarios. Only then it's meaningful. If it's going to work only in isolated cases, people still believe in such things, but you need belief. You need faith. It's not a proper scientific theory in some sense. Okay, so here we're interested in such scientific theories. Okay, now let's look at situations where it seems like there's a pattern, but the scenario is very complex and you can't write simple equations for it. Okay, so I've put together here like 4 examples for you. Or maybe these examples are not that relevant, but still you can see that the complexity can quickly go up even when simple things are involved, and suddenly the situation becomes complex. So let me start with the first example here, which is tossing a coin, right? You've seen people toss a coin and they expect the outcome to be sort of random, right? You cannot predict ahead of time whether it's going to be head or tails. But why is that? Why is that? When someone tosses the coin sort of takes off from their finger. It keeps flipping depending on how fast that initial tip was, the initial push from the finger, flick from the finger was. Okay, it keeps twisting and turning, and it's going to fall down. It's going to fall at some angle, and depending on where it falls and depending on the ground, it may roll, it may do a tumble, or it may just fall flat. There is just so much going on, and there may be a breeze in the air, and that may affect it. There may be some particles in the air. Who knows? So even though the equations of motion for the coin is well understood, by the time you apply it with all the unknowns and equations, you will not go anywhere, right? By the time the coin would have fallen and somebody would have known whether it's head or tails, you don't need to write your equations anymore, right? So when the situation is even mildly complex, it looks like we cannot write simple equations and know for sure what will happen. Okay, so that's a simple example with a coin toss. You can push this a little bit. The next example I put there is a pair of dice, right? So you throw a pair of dice, some numbers show up. Okay, now you might say, of course, the motion of the dice and all is well understood. Once you know the position, you can calculate where it's rotating, etc., etc. But by the time you finish all that, the dice would have already landed and you would already know what the number is. There's no need to do all that. Okay, so you can quickly see how even a mildly interesting phenomenon can become impossibly complex to write equations for and have precise deterministic theories explaining what will happen. And let's look at more complicated phenomena which are very, very important in practice, right? So for instance, the third picture here shows the annual rainfall map of India. Now, being able to know how much rain is going to happen in what states is a huge plus, isn't it? So you can decide what to plant everywhere, and it changes the economy fundamentally. Okay, can you understand how rainfall is going to work? Can you be very precise about it? Can you say this is the amount of rainfall this part will get? Largely no, isn't it? So, but still you see some predictions coming out. It seems like they're all not deterministic. You can't be sure, yes, this is exactly what's going to happen. It's not something you can say, right? So you can only say, okay, maybe this will happen, this can also happen, this is most likely to happen, this is the chance that this will happen. You'll hear words like this being uttered when talking about rainfall. Let's take a more interesting and maybe more lucrative, right, area into consideration, which is the last picture here. I don't know how many of you recognize that picture. That's a picture of the stock exchange in Dalal Street in Bombay, right? The Bombay Stock Exchange, which deals with stocks and trades and things like that, and so many other complicated things which I don't understand. But there is a value for every stock, right? And depending on after you buy whether the value goes up or not, you can make or lose a lot of money. In fact, today's stock markets are so complex that even if the stock value goes down, you can end up making money apparently. Okay, so there's all sorts of complicated products out there. Let's not go into it. This is not a course about the stock market. But notice, if you want to predict the value of a stock, once again, the situation is quite complex. So many people can trade on that stock from different places in the world, across the globe, and even on the ground on the BSc, right? So much trade can happen, and all of that determines the stock price. Not just that, news about something, or whether there's a financial crisis, or whether there's a storm somewhere, etc., etc. All of that affects the stock market. So maybe you can't have a deterministic answer to what's going to happen to a stock, but even a prediction on what's most likely to happen, what is the chance of something to happen, can help you make decisions on whether or not you want to buy stock, and that can make or break your bank account, etc., etc. So it's very lucrative, and it's a very important phenomenon to study. So here are 4 different phenomena I pointed out. A couple of them seem like sort of toy examples, tossing a coin, throwing a die, seems like toy examples. But a couple of other examples are very important in practice, and these are all very complex, and it's not going to be worth your while to make deterministic predictions or theories on it. But can you make any prediction at all? Can you say something with some chance, and can you put it to use, and can you benefit from it? Okay, so these are the kind of questions that naturally occur, and So generally now, how do you start looking for patterns when the situation is so complex like this? How do you start explaining these patterns? Is there a theoretical framework, right? Newton's mechanics gave you a theoretical framework for studying these phenomena. Is there a theoretical framework for situations like this, for random-like phenomena, where it looks like there is nothing deterministic that one can say about the phenomenon? Is there a theory? Is there application? Can you make use of it? Can you answer some questions based on these things? So all of these things are natural questions, and believe it or not, in this particular course, we're going to make progress towards understanding these things. I mean, you're not going to be able to predict stock market values based on this course, but at least we'll take a step towards that, right? So you'll go towards understanding a random phenomenon, how to think of them theoretically, how to use them in applications, how to make predictions based on them, and how it's useful. So that's sort of the big picture of where this course is, and that involves data, statistics, probability. All three are involved in that in this kind of analysis. Okay, so in particular, we will be doing what is called statistical study of what looks like patterns in random-like phenomena. Okay, so I was talking about this even in the previous slide, so let me not spend too much time on this one. When a phenomenon is very complex, it looks like we cannot have exact simple models. I gave you examples of how all these three particular situations work out, but still there is a pattern. Okay, so there is a pattern, isn't it? So you can see, if you have a coin which you believe is fair, if you keep tossing it for a long time, if you repeatedly do it, you expect half the time it to be heads, half the time it to be tails, right? So that's a pattern. So maybe there is a theory which can sort of predict that happening. So similarly for rainfall, you see people make a statement, like for instance the meteorology department will make a statement saying there is 70% chance of rain tomorrow. First of all, what do they mean by that? What is the 70% chance? How do you interpret it? Do you take an umbrella with you if they say 70% chance, right? So likewise, even for monsoon, they make predictions. It's going to be average monsoon, below average, above average. They make these predictions. What is the meaning of these predictions? Where do they come from? How is there a theory behind this, or is it somebody just guessing? What is going on here? So similarly with the stock market, even though it looks to you like it's very random, the trading companies hire a lot of statisticians and professionals who can track trends in the stock market, and they use a lot of statistical study and analysis for it. So it looks like, even though the phenomenon looks very complex and very random like, there are some hidden patterns and nice structures. And is there a theoretical what is the theoretical framework for studying this? How do you apply these things using the theory is something very interesting, and that's what we will do in this class. So specifically, we will do what is called statistical study. Okay, you already seen statistics before, it's not new to you, but we'll take it a little bit more forward and study slightly more complicated scenarios. Okay, so if you want to put it in very mild terms, basically you collect observed data, and then you use probabilistic analysis. You use probability as a tool to make inferences about the data, to make predictions about the data, okay, to learn more from the data that you have. Okay, so this is the nature of statistical study, and one can even say, it's had a huge influence in the modern world. Okay, so you can sort of say it's last 120 years, statistics has become really taken a stranglehold on so many different diverse areas that people use statistical ideas everywhere. And in today's machine learning data driven world, it's become very important to understand the fundamentals of statistics, probability, data, and what is the interplay between the three of them. Okay, so this course hopefully will illuminate some of that interplay and get you practice with understanding what data is, what is the pattern, where is the probability theory that talks about it, and where is the statistics that's going to come in. Okay, so here is a picture that I've just drawn these three things together, and it's a good picture to sort of keep in your mind. I think other people might draw other pictures differently, the same picture sort of differently, but this I think is hopefully useful to you as you go along in this course, or maybe even in this entire program, to understand what all this is about. Okay, so in statistical studies, we are looking at data that comes from the real world, from some phenomenon or any problem that you might attack, right? And you want to see if there are patterns. So how do you do it? you use statistics and probability. So probability is like the theory, and you can think of statistics sort of like the application as to how you derive useful things from the data using probabilistic analysis and probabilistic models, and you make inferences. Statistics gives you the tools and methods and ways of answering questions about the data, again that's making predictions about the data using these methods. Okay, so this picture is a nice picture. I'll try to repeatedly use this picture in this class so that you get an idea of how these things work, and in many of the examples that we study, we'll have this going. Okay, so even though we'll study each of these things separately, we'll study the probability part separately, we'll study the statistics part separately, we'll have some running examples that run through and connect all three of them together for us. Okay, so this is probably a good way to capture what the ambition or the aim of this course is, and we'll see as you go along how much of this gets through correctly to you. Okay, so that's the introduction for the course. I mentioned before that there is this activities in this course which will give you 10 bonus points. Okay, so I put here this will involve several activities. This will account for 10% of your marks. Account meaning it will give you a bonus of 10% for the marks. Okay, so this account is not entirely the correct usage. So it will give you 10% bonus marks. Okay, and I'll assign activities for you every week, maybe 1 or 2, or maybe some weeks no activities. Okay, I'll assign some activities for you. Depending on what fraction of those activities you complete, you will get some marks. You can get 7.5, you can get 5, 2.5 or 0 marks depending on how many activities you complete. And there's also a bonus that I might give. If you do some of the activities exceedingly well, you may get a bonus. And but overall it's just 10%, and like I said, it's a bonus on top of what you already have, right? So if you don't want to do it, you don't need to do it, but I would strongly advise that you do these activities because it can go a long way in helping you understand and clearly grasp ideas in this subject. Okay, so these are the activities. So let's begin with week 0's activity. Already week 0 has an activity. There are more activities coming in week 0 itself, but this is activity 1 in week 0, and in this you will create a Google Sites web page for yourself. Okay, so it's a simple menu driven activity that you need to do. So let me show you how this is done. So you have to, so I put down the list of things to do on this in the slide, but let me also show you ready-made by hand how I do this. I go to this site called sites.google.com. Okay, I'm logged in with my online degree ID, which you should also do. You can see you will probably have your roll number at student.onlinedegree.iitm.ac.in. Please log in with that ID. And then you have to create a new site. Okay, and you have to use, there is a template gallery which has templates for several different sites you can create in Google Sites. I want you to pick the student portfolio. Okay, so you notice the student portfolio, there is a template called students portfolio. You click on that, that will create a new Google Sites for you, which is according to the students portfolio. Here you can change a lot of things, like for instance you can change the image. Okay, I'm not going to change the image, but you can change the image. When you reset some header type, you can change a lot of things. Okay, you can add, apparently you can add a logo here, you can add some sidebar, you can do a lot of things here. So this Google Sites is a very simple way to create a web page. Okay, so I'll tell you how this web page gets published. Right now you're just creating. You can publish this web page also, but you know, maybe you want to put your name here. Okay, you can put your name here, so maybe I'll put a name. Okay, so it's my learning journey, it says. You can scroll down, you can write about me. Okay, so once you've created this site, you'll get a URL which you can potentially give to others, but I'll tell you about what you want to do with that, but this is what it is. So you can put more things here, you can edit it, you can see, you can keep editing whatever you want. Okay, you keep editing and editing and editing. You can put a lot of things. I mean, so many, every one of these things is editable. Okay, you can add some strengths if you like, some goals, just depends on what you want to put out there. You can also add other things, you can create more things here. right? So you can do a lot of things. Google Sites is quite powerful, but this is not a course on Google Sites, it's on statistics. So what I want you to do, if you go to pages here, you will see there are something called classes. Okay, so you can see I can rename this math to, let's say, statistics 2. Okay, right, and this is part of your template, the student portfolio template. As a student, you are expected to take classes, so you take classes and you click on statistics 2. It takes you to the statistics 2 page. So now this is not math anymore, so you can make it statistics 2. You can write a summary of what you're learning in this class, data, statistics, and probability. That's probably a good way to summarize what this class is. You can write whatever else you want, and then you can keep making, you can keep adding things one after the other. Okay, more and more topics, whatever you learn, you can add here. This is your email, your website controlled by you with your email address, so you can keep adding more and more that you want. You can go back to the home page. It comes out here. You can see the sidebar is here. It says statistics 2. All of that comes. So you can see all this. So now we're ready to publish. So let's say we publish this site that we have created. So you click on publish. You will get a link here. Okay, so it asks you for your publish your site. Okay, so this is the kind of URL that you will get: https sites.google.com/onlinedegree.iitm.ac.in/ you can put your name. Okay, so let's say, what name do we want? Let's put Andrew. Okay, so that's the name, and it's okay with that. So who can view my site? Anyone at IIT Madras. Now I'm going to ask that you do not change it. Okay, if you click on manage, you can possibly make it public or something. I want you not to do it. This is going to be your internal site. Maybe later on you can think of having a public version of it, but as far as this course is concerned, you should not be making it public. Okay, so this should be a site that we maintain. So if you want to do that, you can say here Andrew as a student or something. It's okay. You can just leave it like that. It's okay. So you can give another name for it if you want. So you can say Andrew Learn or something like that. Okay, so that if you want to create your own site, it doesn't clash with the name, right? So you can do it like this. Okay, so let's say we publish this. Okay, so it's publishing. Once it's published, you'll see this little arrow that is shown up here. You can view the published site. You can also unpublish. Okay, you can stop it if you like. You can view the published site, which I recommend that you do. So you can see it has come here. It has come to the statistics 2. You can go to the home. So this is your sites, right? So this is sites.google.com/online-degree Andrew Learn. You click on it, you will get access to this. Of course, only people with online degree logins can see this site, which is what I want you to keep it as. Don't publish it to the whole world. Okay, so it says Andrew's Learning Journey. It's a website. You can whatever you put here will show up here. In particular, you go to classes and statistics 2. You see what you have in statistics 2. Okay, so now everything we do, all the activities we do in this class, you will keep adding here. Okay, this is the published version. This is your editing version. So you can keep adding here. Like for instance, instead of geometry, let's say I want to change it to week 0. Create my student portfolio site. Okay, I've done that. So now you have to publish again. You can review changes and publish if you want. It will show you what has been changed. Okay, so you can just say publish. It's okay. Right, now if you go to this page and you refresh, well, eventually you will get it. It takes a little bit of time to propagate sometimes from one part to the other. Yeah, it's come. So you see week 0, create my student portfolio site. Okay. So as we keep progressing in week 1, week 2, even in week 0 you may have one more activity to do. You can keep adding them here in the topics. You can add week 0, maybe you want to make this week 0 activity 1, okay, so that it's clear what it is, and then you can publish also. Okay, so it will get published eventually. You will see here week 0 activity 1, and then as and when you get more and more activity, you can add that here very easily. So this is one place where all the activities that you do as part of this course are captured. Okay, so hopefully this is interesting to you. Like I said, it's optional in this class. You don't need to do it if you don't like it, but I hope you enjoy it. It's a site that you can create, and you can do other sites as well. Once you create one site, you can create other sites on sites.google.com. It's a very easy way to create a web page for yourself in some way. Okay, so that's the end of the first part of the week 0 lecture. I'll come back in the next lecture and talk to you about a data set that we are going to use in this class as a running example. Okay, thank you very much.